Hey, if you're here for a refresher on solving ratios. They come up all the time in triangles, and especially in similar triangles here, we solve with them all the time. Now, we are going to take, let's say x over 2 equals 8 over 5. So this is the ratio. Now, we get these a lot in similar triangles, and we always want to set the x up on top. It's easier to solve that way because all we have to do is cross multiply. We just, boom, multiply that 2 up there. But why? Why does cross multiplying work? Because cross multiplying is one of those shortcuts. It's one of those shortcuts like, well, do you remember this shortcut? If I've got x minus 2 equals 4, what do? Well, I bring the 2 to the other side, and it becomes a plus 2 when it comes to the other side. If it goes over the equal sign, we switch its sign. So x equals 6. Now, that in itself is a shortcut. When it crosses the equal sign, we switch its sign. It's a truth. It happens all the time. But where it comes from is minusing, well, or adding 2 to both sides. So if I have x plus 2 equals 4, shoot, wrong question. That's not what I had. I had x minus 2 equals 4. What I'm really doing is I'm trying to get the x by itself. This is like first principle solving. I'm trying to get the x by itself, so I do the opposite of this to both sides. I add 2 to both sides because that maintains balance. These cancel out. This adds to 2, so I get x equals 6. Now, we shorten that up to just thinking about moving things over and changing the sign. But from first principles, we want to get x by itself. We need to get rid of this, so we do the opposite to both sides. Just like when I have 3x, and that's equal to 12, I want to get the x by itself, so I divide both sides by 3. Why? Because that's the opposite of what this 3 was doing. This 3 was multiplying to the x, so I divide both sides by 3. It cancels out, and x equals 4. Cool? Now, what's going on here? Well, I've got an x that's being divided by 2. So I do the opposite to both sides. I'm going to take both sides of this equation, and I'm going to times it by 2. So I'm going to times this by 2, and I'm going to times this by 2. Now, what's x times 2 divided by 2? Well, times 2 divided by 2 cancel each other out. It just goes to 1x. And what happens over here? Well, here's what happens. When I multiply by 2, multiplying a fraction times a whole number, remember that this is just like 2 over 1. Multiply top times top, bottom times bottom. So I get 16 over 5. Now, again, instead of doing all this, I just remember that it's always over 1, so I just multiply the whole number into the top. So that goes to 16 over 5. Same thing. You can forget about this 1 because it's always just going to be, well, 1 doesn't change anything. Okay, so multiply that into there. So what I'm doing is to get rid of the thing on the bottom, I multiply both sides by whatever that thing is. Okay, I got to clean this up a bit. That's better. So the shortcut to this, when I have x over 2 equals 8 over 5, is I cross multiply. Whatever is on the bottom can cross up and cross multiply to there. So x will equal 16 over 5. Done. Exact same answer. Now, let's try this again. So x over 3 equals, that's not an equals, undo, bam, bam. X over 3 equals 12 over, I don't know, something that doesn't divide by 12, otherwise we would have just reduced it. Sorry, I'm talking out loud. Let's say 12 over 7. Okay, so if this is the thing that I set up, I multiply both sides by 3, which effectively does this. Just multiply that up. So this goes to 36 over 7. Now, you could leave it like that, or like 16 over 5, but I would rather you change this into a mixed fraction. Why? Because what I'm doing here when I'm solving ratios for similar triangles is I'm trying to find the side length of a triangle. How long is 36 over 7? I'm not sure. But if I change it to mixed, this is 5 and 1/7, I get a much better idea of how long 5 and 1/7 is. So if we're talking feet, I know that that's 5 and 1/7 of a foot. I can approximate that. It makes sense. 36 over 7 feet doesn't make any sense. So change these into mixed. So this one I should have changed into mixed too. This one is 3 and 1/5. Yeah. These are better. Okay, now, last one. Oh, sorry, phone's going off. What if x is on the bottom? So let's say I have 4 over x, and that's equal to 5 over 8. That's not an 8. Whoop, whoop. Now it's an 8. Okay, so if 4 over x is equal to 5 over 8, what I have to do is I have to cross multiply a whole lot more. I multiply both sides by x, and what that does is it makes the x come up here. Again, if you want to show all your work, the x on this side will cancel out with this x, and the x on this side will multiply to the top. Now I can do the same thing with the 8 at the same time. It crosses up there by multiplying both sides by 8. So what I get is I get 4 times 8, which is 32, and I get 5 times x, which is 5x. Cool. Multiply that up there, that up there. Now I've got 5x, I just want x, so I divide off the 5, cross that out, and then change it to 6, and 2 over 5 equals x. All right, so if the x is on the bottom, I have to cross them both up, and then I divide them both out. This, well, it's a pain, so I don't do it. This is more difficult than this or this. That's why when I'm doing similar triangles, I always put the x on top. It just makes the solving easier. Well, sometimes we're going to have to put an x on top and bottom. I'll show you that when you get there. But this is why we always put x on top. This is how cross multiplying works. This is the logic behind it. And then, yeah, cross multiplying. Cool? Get back to it.